Given the rational function f of x equals 3 over x squared minus 1, find all asymptotes, intercepts, asymptote crossings, and find the actual graph. Okay, now we're going to go all the way with this. We're not going to stop when we get the asymptotes and the intercepts. Okay, step 1, we are going to divide the top by the bottom, and in other words, we're going to factor and cancel. And so we write this in the form f of x is equal to 3 over parenthesis x plus 1 times x minus 1. Now the intercepts, we are able to find them by setting the y value, the x-intercept, we find by setting y equal to 0 and solving. And when we do that, we know that the entire fraction would be 0, and for the entire fraction to be 0, we have to have the numerator equal to 0 in a fraction for the whole fraction to be 0. So that means that 3 is equal to 0. No, that's nonsense. Throw that away. There's no x-intercept because the top cannot be equal to 0. It's just the number 3. For the vertical asymptote, we're skipping to the vertical asymptote. These are the x equal the real zeros of the denominator. So we're going to set the bottom equal to 0 and solve for x to get the equation of the vertical asymptotes. When we set the bottom equal to 0, in its factored form, x plus 1 times x minus 1 equals 0. Set each of the factors equal to 0 to solve this x plus 1 times x minus 1 equals 0. The first factor gives us x equals negative 1 when we solve for x. The second gives us x equals 1. Those are equations of vertical lines. Those are our vertical asymptotes. Step 4, we'll find the y-intercept by letting x equal 0. So f of 0 equals 3 over 0 squared minus 1. It's equal to negative 3. So our y-intercept is the ordered pair xy equals 0, comma, negative 3. Now, for the vertical asymptotes, horizontal asymptotes, we're going to compare the degree of the top and the degree of the bottom. So I wrote t with a little 0 exponent. That means the top's degree. The top's degree is equal to 0, and we're going to compare that to the bottom b to the 0 power of the bottom degree is equal to 2. I'm just trying to save space here. So we see that the top degree, 0, is less than the bottom degree. And what does that mean? According to our notes, it means that the horizontal asymptote is the equation for the x-axis. It's the equation y equals 0. Okay, now remember, this equation for the horizontal asymptote is of the form y equals the number c. And whatever that c is important for the next step. So if the equation of the horizontal asymptote is y equals c, what is c in step 5? The c value is equal to 0. We're going to use that. We're going to go to step 6 and say, let f of x equal c. And we noted that c is equal to 0 in this step 5. And then solve for the crossing point of the horizontal asymptote, because you recall I told you it's always possible to get a crossing on the y-asymptote, the horizontal asymptote, not the vertical, but the horizontal. It's possible. That's what we're checking for. Okay, so we set the entire f of x, the entire fraction, equal to the c value, which we found to be 0 in step 5. Now we are going to solve. It's interesting because this is just the same as finding the x-intercept. That's not always the case. It's because the c value happens to be 0. Sometimes it's a different number for the horizontal asymptote, but this time it's the 0, which means that the numerator has to be equal to 0, and that implies that 3 has to be equal to 0, and that's ridiculous. That's never going to happen. So there are no crossings at this asymptote, and we're happy and satisfied with that. So don't always expect that you're going to get this equation that's the same as finding the x-intercepts. Don't make the assumption that the x-intercepts are the same as the crossing of the asymptotes. That only happens when your horizontal asymptote is the x-axis, the equation y equals 0. Okay, moving on. Slant asymptote. No, to have a slant asymptote, the degree of the top has to equal the degree of the bottom plus 1. And that's not the case with ours, that has the degree 0 for the top and degree 2 for the bottom. Okay, steps 8 and 9, we're going to draw all this information that we have established on an x and y axis. So let's see, let's draw our x-axis and our y-axis. And we'll put some numbers. You always have to label a few numbers on the axis so I'll know what's going on here. Otherwise I'll forget what point is what. Okay, so I'm going to draw the vertical asymptotes and the horizontal asymptote. Verticals occur at x equals -1 and x equals +1. I'll even identify them here on the graph. Here's x equals +1. And then we have a horizontal asymptote at y equals 0. See the dotted line across the x-axis? That's the equation y equals 0. And we have some intercepts. We have, let's see, well, let's get a few points here. Hold on. We had no x-intercepts, and we had an intercept at 0, -3. So we do have one y-intercept. But we need some more points. And don't forget, before we look for these points, don't forget, these graphs will never cross their vertical asymptotes. Never. They'll just hug and get close, but they'll never cross it. They can cross the horizontal, but we just looked in step 6 for the points where they cross the horizontal asymptote, and we found none. So this graph is never going to cross any of its asymptotes. So keeping that in mind, I think all we need to find are 2 points, and I think we'll have enough. Let x equal 2, and then we get the y equals 3 over x squared minus 1, and that will give us 1. When x is equal to -2, plug it into the equation and we'll get 1. So let's graph these two ordered pairs. 2, 1 is, let's see, go 2 on the x-axis and up 1 on the y. There's that point. And then -2, 1, go to -2 on the x and up to 1 on the y. There we go. And of course we have our intercept at 0, -3. Now, since we know this graph will never cross any of its intercepts, it is destined in the center region to go down through, after it goes through its y-intercept at y equals -3, it must go down on both sides. All right, and the reason I say it has to go down is because that intercept it's never going to be able to cross. It's never going to be able to cross. Now you're saying to me, why couldn't it have gone up? Well, the fact of the matter is it could have gone up. I should have checked some points closer on the other sides of the two vertical asymptotes to be sure. I should have done that, and I didn't. But let's talk about what's happening for values of x less than -2 and values of x greater than 2. Well, we checked some points. We found the ordered pair 2, 1. And so the graph has to pass through the point 2, 1, and it's trapped in that upper right region since it can never cross the intercepts. It has to go, the asymptotes. It has to go through the point that we have, but it can never cross the dotted asymptotes, so it's stuck right there. It's going to always go forever, just getting closer and closer to the asymptotes. And a similar thing happens on the other side, where we find the ordered pair -2, 1, and that graph has to pass, that region has to pass to that point and never cross any of the intercepts. So that gives us our picture. So my only objection to my work here is that I should have been a little more careful about what happens in the middle region. I really had no reason to believe that both sides went down. Maybe they both went up. Maybe one went up and the other went down, and they just never crossed the vertical asymptotes. But I really should have found some points, like I should have let x equal -0.9, something like that, to find out what's happening on the left, and let x equal 0.9 to give you what's happening just to the left of the right side asymptote. Let x equal -0.9 to see what's happening on the just to the right side of x equals -1, and then we would have been more confident in that picture in the middle.